Our question asks us to find the volume of the shape formed when sine x from pi over 2 to pi is rotated around the x-axis. So now let's just see what that looks like. So let's just draw y equals sine x real quick. So we have sine x goes from 0 to pi, so that should be good enough for now. So this is pi, and this is pi over 2. So sine x from pi over 2 to pi is rotated around the x-axis. So it should form some sort of shape like this. So it'll look like a sort of plug-like shape. So we want to find the volume of this. So we can do that by integrating all of these circles. So if we were to find the area of one of these circles, then the radius would be sine x. And we know from the equation of the area of a circle, the area is pi r squared. So pi times the radius squared, in which, in this case, it's sine x. So to find the volume, all we have to do is find the integral of the radius squared times pi. So we're going to take this integral from pi over 2 to pi, and it's going to be pi r squared, where r is the radius, and that is sine x. So we have pi times sine x squared, and we're going to have this integral with respect to x. So how will we take the integral of sine squared x? Or another way of writing it is to have the square right after the word sine. They both really mean the same thing. So to find this integral, we'd have to somehow simplify sine squared x. And lucky for us, there is a way. And that way is to use the double angle formula. So we know from the double angle formula that cosine 2x is equal to cosine squared of x minus sine squared of x. And we know from the Pythagorean theorem that cosine squared of x plus sine squared of x is equal to 1. So by rearranging this upper equation, we can get cosine 2x is equal to 1 minus 2 times sine squared x. So we get that by plugging in cosine squared x equals 1 minus sine squared x into this above equation. And now if we solve for sine squared x, what we are going to get is sine squared x equals 1/2 1 minus cosine 2x. So now we can plug this side in to this sine squared x. So let's do that. And what we are going to get as a result is going to be pi, the definite integral from pi over 2 to pi, and sine squared x. And that's just going to be 1/2 1 minus cosine 2x dx. So now if we take this integral, what we are going to get is pi times, so 1/2 times 1 is just going to be 1/2 of x, and 1/2 times cosine 2x, well, the integral of cosine 2x is 1/2 sine 2x. So if we have this 1/2 times another 1/2, we are going to get 1/4 sine 2x evaluated at pi and pi over 2. So if I draw just a line over here, if we continue this on and evaluate this definite integral, then what we are going to get is pi times, so we have 1/2 pi minus 1/4 sine of 2 pi. Well, we know sine of 2 pi is 0, so that doesn't really matter. And now we subtract this evaluated at pi over 2. So 1/2 of pi over 2 is pi over 4 minus, now 1/4 of sine 2 times pi over 2 is 1/4 sine pi. And what we know from trig is that sine pi is also 0. So that's just going to be 0. And now we can simplify this. Well, 1/2 pi minus pi over 4 is just going to be pi over 4. And then if we multiply another pi, then what we are going to get is pi squared over 4. And that is the volume of the shape formed.